Hey everyone, we're here looking at vectors. This is a physics concept in the sense that forces and other things involve vectors, objects that move involve vectors, require vectors, and we're using it here in pre-calculus because of our discussion on law of cosine and law of sine and how they are going to be a great tool in working with vectors. So, looking here, a couple of things to note. There's this concept of a resultant vector. So the resultant vector is the sum of two vectors, okay? So if I have two vectors, let's just say u and v, the resultant would be u plus v, okay? This is the resultant. Now, I'm going to give you just a generic picture of what we could have. So I could have some vector, some force in this direction, this could be u, and I can have some force pulling the same object in this direction, pulling or pushing, and that could be v. So the resultant vector is the sum of those two. So if I were to apply these two forces on this object, whatever this object is, the resultant vector is going to be how the object behaves. All right, so there is one concept here. It's a method. It's called the parallelogram method. I was about to say the Pythagorean. This is the parallelogram method. And what it says is the resultant vector, the location of the resultant vector, is it's the diagonal within the parallelogram. Okay, so what I'm going to do is I'm going to move this vector. I'm going to slide it down to the end of this. So think the tip to the end of this, or sorry, tip to tail. So I'm going to place the end here, bring it down here. So it's going to look like this. All right, so I just slid it down. And then the same can be said with the bottom vector. I'm going to slide it up. So in doing so, we get a parallelogram because I just slid this vector up and this vector to the right. So the sides are parallel, hence parallelogram. So the resultant vector is going to be this vector here. So when we wonder how is the object behaving when these two vectors are applied, well, this would be the direction. We'll have angle measures and actual magnitudes involved with this as well. Okay, so this is our resultant, u plus v. So let's try that. I mean, this is just a basic, very, very non-descriptive picture of what we're going to have. Let's just look at the problem. So you can see I mentioned the parallelogram properties. Yeah, we'll get to that. So two forces of 692 newtons, that's the unit for a force, 423 newtons act at a point. The resultant force is 768. So I'm going to draw these two. Now with this, much like surveying problems as I discussed in a couple of videos ago, it doesn't matter how we draw the pictures when we're not given any sort of angle measures. So I can just draw my point. I have my 692 Newton force, and we have our 423 Newton force. And saying that the resultant force is 786, that's saying if I were to, again, think of our parallelogram, moving this to the right, I would be saying that the resultant force, this force here, is 786 newtons. Now, how in the world, given this diagram, how could we find the angle between these forces? Okay, so we're looking for what is this whole angle, going from the 423 to the 692. Okay, now with the diagram we drew, do you see a triangle? Hopefully we have. So we move this vector to the right, which means we know that this is also 692. So now I can imagine, oh, this is not here. Now I know I'm finding this angle, but I'm not going to be able to find it right away. So I have, well, it looks like side, side, side. I'm thinking I'm using law of cosine in this problem. So when we use law of cosine, abbreviate that, we also understand that it's going to find us this angle measure. Again, based off the sizes, we have the largest angle. All right, so we'll have this angle measure. Understand that. To find our actual answer. So this whole lesson's about getting the diagram, hence drawing diagrams, but also getting it to a point where we just have, computation remaining. Knowing that we have this angle measure, let's say we have our parallelogram. Just going to draw a generic parallelogram. We're going to find this angle measure, okay? We desire what was this left angle, okay? One thing we do know is that the two angles within a parallelogram, when they're adjacent or consecutive, that the two angles have a sum of 180 degrees. So if I desire to know this angle, once I use law of cosine to find our inside angle, that's really arbitrary in the sense of it's not there, we're looking at this one. So we have 180, so beta, we'll call this angle beta, or any variable, x, y, z, whatever. It's going to be equal to 180, taking away the angle that we found. Okay, so starting here, we drew our diagram, created the parallelogram, which I should have at the top as well. So we have that, and with that parallelogram, we have a triangle within it, using law of sine or law of cosine to find an angle measure or side length, and using the properties of a parallelogram. So I'm saying here that the sides are parallel. Using the properties of a parallelogram to find our desired angle. So let's look at another situation. Again, dealing with vectors. So vector u has a magnitude of 15 and a direction of 0 degrees. Vector v has a magnitude of 18 and a direction of 70. All right, so we're given angle measures, so we are limited to how we can draw this. So this first vector is saying it's 0 degrees. Okay, so 0 degrees, again, with bearing we saw 0 degrees was at one location. We're back to thinking that 0 degrees is what we could say is horizontal, or flat, even if you want to say it that way. So this is vector u, and its magnitude is 15. Then at a 70 degrees, we have vector v with a magnitude of 18. And we desire to know the magnitude and direction of our resultant vector. Okay, so how are we going to do that? So this is 70, by the way. So it's not, the angle is not going to be 35. Do not think that's going to be half of this angle, okay? So what we can do is we can make our parallelogram. And we desire to know, first of all, this length. That's the resultant. So we desire to know this length. Okay. Well, knowing our property up top here about supplementary, if this is 70 degrees, then I would know this angle measure, right? Right? Yeah. So this is 110. Okay. So it's 110, and we know that this right side is 18. Yes, because properties of a parallelogram, opposite sides are congruent. You knew there was a reason for learning all these properties, right, in geometry, not just sitting through the class. You actually use the properties elsewhere. Right, so looking here, we have, all right, so I have this obtuse triangle. We have 15, 18, and 110. We desire this length. That looks easy enough with law of cosine. All right, that's going to give me my side length that I desire. And once I have that sine length, couldn't I then use for our angle, the direction? Couldn't I then use law of, well, so we haven't used theta yet. Couldn't I use law of sine to find our angle? I think so. So it's going to be this lower portion since we're measuring it from the 0 degrees. All right, so we're going to be practicing this more. This is actually a concept that we're going to be visiting again in Unit 7. I believe that's our next unit, dealing with vectors, vector addition, and other things with vectors. So we'll come back to this after practicing more with law of sine, law of cosine. But good luck as you continue on here using law of sine, law of cosine to solve actual application problems.